My lecture topic is automotive final drive. In the final drive mechanism, there are several types of final drives are there. To turn the drive through 90-degree, a straight bevel gear or a spiral bevel gear or worm gear drive is used. First one is straight bevel gear type. The final drive type, straight bevel gear type is used. Originally, straight bevel gear type of final drive was used where the axis of both the wheel and pinion were intersecting at exactly 90-degree. But it was observed that this type was noisy even when made very precisely and assembled and carefully. The functioning of straight bevel gear is analogous to spur gear with similar drawbacks. Therefore, spiral bevel gear's drive is preferred as final drive gear unit in later versions. A straight tooth bevel gear final drive and the spiral bevel gear type is both are almost similar, but in spiral bevel gear type, a smaller gear attached at the end of propeller shaft is called a crown pinion, and its mating gear, larger one, is known as crown wheel. It has the advantages similar to helical gear drive, namely gradual tooth engagement and therefore gradual and smooth load transfer, lesser gear noise, larger load carrying capacity, etc. In the case of spiral bevel gear final drive, the axis of crown wheel and pinion intersect at the wheel center. This makes the ground clearance to be more. In this type of final drive used in passenger cars, then the center of gravity of the car will go up. The requirements of a tunnel around the propeller shaft, which will be interface with passenger comfort, will engage. Therefore, it is not preferred for the passenger cars. In hypoid, the third different one type of bevel gear is hypoid bevel gear type of final drive. In this case of final drive, the stability of a vehicle increases with a decrease in the height of the vehicle. So the vehicle height should be always minimum. That is a requirement. A small displacement of the crown pinion in the downward direction helps in improving the vehicle stability to a large extent. This is made possibly by using a hypoid bevel gear as the crown pinion in the final drive in place of spiral bevel gear crown pinion. The usage of a hypoid bevel crown pinion allows lowering of the crown pinion shaft by a small amount, which in turn allows lowering of propeller shaft location. This leads to reduction of height of vehicle center of gravity, thereby increasing the stability of the vehicle. So in this case, if you use the final drive, the stability of the vehicle should be increased. That is the main purpose of the this hypoid bevel gear type final drive. Also, a hypoid bevel pinion permits usage of lesser number of teeth, such as 6 to 12, without undercutting. 10 to 12 teeth on crown pinion of hypoid bevel gear is common. Thus, the overall size of the final drive can be reduced considerably, which again helps in improving the stability. Further, the usage of hypoid gears also allows the pitch diameter of the pinion to increase with the pinion offset. This leads to the usage of a larger pinion for a given size of crown wheel. This increases the pinion tooth strength by about 25% and gives a greater pitch overlap. When corrected meshed, the arrangement will result in silent running of the gears. A pinion offset of about 0.2 times the crown wheel diameter for passenger cars and about 0.1 times the crown wheel diameter for heavy vehicles is generally used.